All right, this podcast will cover ICMPv6. When we updated the IP protocol to version 6, we also needed to update the ICMP protocol to go along with that. Originally defined in RFC 1885 and was updated by the RFCs listed on the slide. We have the same type of messages we had with IPv4, the error and informational messages, but we also have added some new functionality in ICMPv6. We use ICMPv6 for neighbor discovery, which IPv4 used ARP for that. And we also use ICMPv6 for group multicast membership, multicast group membership, which IGMP was the protocol we used for that in IPv4. So the general format of an ICMPv6 message has the type, code, and checksum. The type and code identify what type of specific message it is, with each of the specific messages having their own format. The first several messages we'll go through are error messages. The first one of those we'll talk about is the ICMPv6 packet too big message. This is used if a packet larger than the MTU comes across. With IPv6, routers will not fragment traffic. There is no don't fragment bit. If you recall from the IPv6 base header, we will not fragment traffic on the router. We don't want our routers processing packets unnecessarily. So we'll tell the sending host, hey, your packet's too big, make it smaller. And the host can either adjust the payload size, or they can use the fragmentation header to fragment the packet at the host. The next ICMPv6 error message we'll talk about is time exceeded. This is when the hop count is decremented to 0, or if the fragment reassembly time's exceeded. So that's what that's used for. Parameter problem, this is if we get a bad field in the header that we cannot process, we'll send back a parameter problem ICMPv6 error message. Those were the error messages we're going to talk about. Here are some informational messages. We have the echo request, right, used for ping, just like IPv4. We have the echo reply, that's a reply to a ping, just like IPv4. IPv6 neighbor discovery, this replaces ARP. This is how we use MAC addresses. This is how we find the MAC address associated with an IPv6 address. Hopefully you know by now that when we want to send traffic, we need the MAC address to send it. So with IPv4, we send out an ARP request. With IPv6, we send out a neighbor solicitation, and we send that out to the solicited node multicast address, right? IPv4, we send out a broadcast request. Neighbor solicitation, we send it to the solicited node multicast address. And a solicited node multicast address is a address that a host will listen to, that it builds based on its IP address, so that it will know the traffic's coming to it without having to know. So let me start that over again. So a host will build its solicited node multicast address based on its IP address. So if a host sends out a packet to that solicited node multicast address, then the target host will receive that, and the sending host doesn't need the MAC address because it's a multicast packet. So once the target host gets that neighbor solicitation, it'll send back a neighbor advertisement that contains its MAC address. We also have the idea of stateless auto configuration we talked about in the IPv6 addressing podcast. That works by an IPv6 host and router sending out router solicitations and router advertisements. So essentially, a host will send a router solicitation when it comes up, if it wants to statelessly auto configure its address, and pretty much says, hey, are there any IPv6 routers out there? And if there's an IPv6 router out there, it will send a router advertisement that contains the prefix information the host can use to automatically generate its IPv6 address and join the network. Router advertisements can be sent in two cases. If the router comes up initially as a router, it will send a router advertisement. It will also periodically send router advertisements. Those are sent to the all nodes multicast address, which, if you recall, that's kind of like the broadcast address. All nodes multicast address. And then if it receives a router solicitation, then it will send a unicast reply to that router solicitation. IPv6 multiclass group membership. If we recall, multicast is when we send one packet that's destined to a group of hosts. IPv4, we use the IGMP protocol to manage multicast group membership. Oh, that's a typo. Let's just say IPv4. That's a typo. Let me fix that. I don't want anybody to get confused on the quizzes or anything. Tell me how to typo. So there we go. So IGMP was used to manage multicast group membership in IPv4. IPv6 uses special informational ICMPv6 messages, and we're not really going to go into much detail about that because we didn't really cover it in IPv4. So that's the basics of the ICMPv6 protocol. If you have any questions, bring them to class or put them on the discussion board posting.